In section 5.4, we begin to look at normal distribution. This involves a normal curve, which is also referred to as a bell curve. This is a specific set of data or a special situation where if you graphed using a histogram or a frequency polygon, the data is completely symmetrical with one single peak in the middle. In this type of data, the mean, the median, and the mode are all in the center at this singular peak, and the left side is symmetrical to the right side, meaning this one starts low and rises to its peak or the mean, and then going from the mean, it drops down to the horizontal axis. Now, when you have a set of normal data, it is proven or approximate that 68% of your data is within one standard deviation of the mean, meaning that one standard deviation to the right and one standard deviation to the left, 68% of this data is within this one standard deviation. And that 95 is within two standard deviations to the right and two standard deviations to the left. And then 99.7 is within three standard deviations. There is some additional numbers that this graph that I've given you has on because the data is symmetrical. Since 68% is within one to the right and one to the left, that would mean that 34 is in one standard deviation to the right and 34 comes from one standard deviation to the left. So if we look at a situation where we're going to use this normal curve, a shoe store is opening up and wants to have shoe sizes for 95% of the people who come to the store. If the average shoe size is 9 and the standard deviation of the data they gathered was 3, what shoe sizes should they order? So what we found from this data is that the mean is equal to 9 and the standard deviation is equal to 3. So we'll draw a normal curve. In the center of the curve is the mean, so 9. And then we're going to draw these standard deviations. So 1, 2, 3 standard deviations to the right, and 1, 2, 3 standard deviations to the left of the mean. So there should be an equal amount of data below and above the data if this is a normal distribution. So in terms of this, one standard deviation, what we would do is we would take our 9 and we would add a standard deviation which is 3. So at this point the data would be at 12. And then if we add 3 from here, so 12 plus 3, this would be 15. And then add 3 again, this would be 18. So what I'm doing is I keep adding 3 because 3 represents the standard deviation, which is the spread of the data from the mean. Now, if we look at this side, since this is below the mean, what we're going to do is take 9 and we're going to subtract 3. So this would give us 6. And then if we take 6 and subtract 3, it would give us 3. Or if you wanted to, it would be really 9 subtract 2 standard deviations, which is really 9 subtract 6. That's the same thing. And then subtract 3 again, that would be 0. So what we're saying with this normal distribution is that 68% of this data is between 6 and 12. 95 is between 3 and 15 because that's 2 standard deviations above and 2 standard deviations below. And about 99.7% of the data is within these 3 standard deviations. So for us, the question is asking how many shoe sizes should they have for 95% of the people who come to their store. So since the average is 9 and the standard deviation is 3, 95% of the data or 95% of the customers should have between shoe size 3 and 15. So the shoe sizes they should order should be between size 3 and size 15. So if they order between these sizes, they should cover 95% of the data. Now, if we look at another example, a school of 130 bottlenose dolphins is living in a protected environment. The life expectancy of the dolphins is normally distributed with a mean of 39. So we know that the mean is 39 years. And the standard deviation is 3.5 years. Now what we're looking for is how many of these dolphins can be expected to live more than 46 years. So again, what we'll do is we'll draw a normal distribution curve. And we'll create the set of data from the information that's given. So we know the mean is 39, which is in the center. Now, if we're going to add one standard deviation, we're going to take 39 and we're going to add 3.5. Now, if we do that, we should get 42.5. Now, when we add two standard deviations, what we're going to do is double this number. So we're going to really do 39 plus 7, or we can just take this number and add 3.5 again. But 39 plus 7 would give us 46. That's two standard deviations. And then 3 standard deviations, we would be adding 3 times this, which is 10.5. So 39 plus 10.5 is 49.5. That's going to the right side. Now going to the left side, we'll do the same thing, except we're going to subtract. So 39 subtract 1 standard deviation is 39 minus 3.5, which is 35.5. For 2 standard deviations away, what we're going to do is double this. So 39 subtract 7, which is 32. And for 3 standard deviations away, we'll multiply this by 3, which again is 10.5. So 39 minus 10.5 is 28.5. Now, what we know from the rules with normal curves is that about 68% of the data is within 1 standard deviation. That's going both to the right and to the left of the mean. 95 are between 2 standard deviations, and 99.7 are within 3. Now we're being asked how many of these dolphins can be expected to live more than 46 years. So 46 on our curve is here. So we're looking at how many will live beyond this time. Now if we look, 95% of the data is represented by from 32 to 46 years. So since the data is symmetrical, that only leaves 5% for the total data, okay? Because 95% goes from 32 to 46. So since this is symmetrical, that would mean there would be an additional 5% total, which is 2.5% on this side and 2.5% on this side of the data going down. So from 46 up is about 2.5% of our data. So if we want to know how many, it's going to be 2.5% of these dolphins. So exactly the amount of dolphins would be 0.025 multiplied by 130, since it's 130 bottlenose dolphins. So this, when we multiply these, gives us 3.25. So we are going to say that about 3 dolphins will survive in this protected environment. Or 3 dolphins, will not survive, but 3 dolphins will live beyond 46 years. For this last question, Jim raises Siberian Husky sled dogs at his kennel. He knows from the data he's collected over the years that weights of adult male dogs are normally distributed, with a mean of 52.5 pounds and a standard deviation of 2.4. Jim uses the information to sketch a normal curve. Jim is super enthusiastic about math, I guess, because he wants to draw a normal curve about his dogs. So the mean, we know, is 52.5 pounds. So this is the center, 52.5. All right. And then from here, we're going to add 1 standard deviation. So a standard deviation is 2.4. So when we add 2.4, we get 54.9. Now when we add 2 standard deviations, we're really adding double this, which is 4.8. So we're adding the 4.8 to 52.5, which is 57.3. And then if we add go to 3 standard deviations, 59.7, it's like from here we're adding another 2.4. So if you want to check, you could just keep adding 2.4 and make sure you get these numbers. And going this way, you could just subtract 2.4. So 1 standard deviation away is going to be 50.1. 2 standard deviations away is going to be 47.7. And then if we subtract another 2.4 to get, we should get 45.2. Or sorry, 0.3. 0.2. Now, we know that 68% of the data is within here. We also know 95% is here to here. And we know that this 3 standard deviations is 99.7, approximately. So what we're looking for is how many will have a weight between 47.7, so here, and 54.9, which is here. Now, this isn't exactly 95 or 68. But remember, this is symmetrical. And on the other side of the page over here, I gave you how each of these break up. Now, if you look, this is half of 68. So this would be 34% of the data. And this side from 47 to 52.5 is half of 95. So half of 95 is 47.5% of the data. Now, if we look at this to find the total percentage, we would take 47.5% and we would be adding 34%. And this would give us 81.5%. So 81.5% of the data, it will be between 47.7 and 54.9, or 81.5% of the dogs will weigh between 47.7 and 54.9 pounds. Part B asks us what percent of adult males at Jim's Kennel would you expect to have a weight between 50.1. So I'm just going to erase these lines I wrote in here and use this curve again. So now I'm looking between 50.1, which is here, and 59.7, which is all the way to here. So I'm looking for all of this data. Now again, I'm going to remind you that this is half of 68, because 68 is 1 standard deviation away. So this is 34% of the data, and this is also 34%. And this, if you look on this side, and it may be helpful to use these little percents here, but this is 13.5%, and this is 2.35. Now, if you add all these percents together, you're going to get the percent that are between 50.1 and 59.7. So there's 2 strategies that I'm showing you here to use. One is to use all these little percents. The other is to divide, figure out what this is half of, and divide this half of the data, figure out the percent, and divide this half of the data, or this portion of the data, in half as well. So this is half of 68 and half of 99.7. So when you add each of these together, you would be getting 83.85%.